confidence interval question, this one. So the amount of coffee dispensed into a cup by an automatic machine may be assumed to be normally distributed with a mean, mu and a standard deviation of 4. Successive amounts are independent. So what was poured into the one cup doesn't affect how much is poured into the next one. One morning the machine was used 50 times and dispensed X, and the amounts dispensed, which each were measured as X, were measured, and it was found that the sum of X was 9,980. So that was what the first dispense was, plus what the second dispense, plus the third, all the way up to what the 50th dispensed cup measured. So we've got to find a 95% confidence interval for the mean amount that is dispensed by this machine. So that means, so if we look at an interval, if we had our mean of our 50 in the middle, our upper bound would be x bar plus 1.96. That's our value for creating a 95% confidence interval, and the lower bound would be x bar minus 1.96 times the standard error. So we know what the standard deviation is, we know what n is because n is 50, there were 50 cups in the sample we took. We've just got to work out x bar. Well, x bar is the mean of our sample, so it's the sum of all the cups, all of the whatever was dispensed into the cups, divided by the number of cups in our sample, and that comes out as 199.6. So we're now in a position to calculate our upper and lower bounds. So if I scroll up, if this will let me, there we go. So my lower bound then will be 199.6 minus 1.96 times 4 divided by root 50. And our upper bound will be 199.6 plus 1.96 times 4 all over root 50. And if we work each of those out, we get a lower bound of 198.5 and an upper bound of 200.7, and that's rounded to 1 decimal place as we were asked.